Welcome to Behringer Talks, the show where we answer questions that you, our customer, have using our 50 years of industry knowledge and expertise. Today, we're going to review our suction regulators and their construction materials. One of the most critical considerations in the design of almost anything is the materials used. This consideration is especially vital in a medical device, as the material forms the foundation that enables the device's proper functioning. Medgas devices, such as regulators, are used in every imaginable clinical setting in a hospital. Suction regulators are called upon to perform everything from routine suction to life-saving interventions by a broad array of clinicians with varied backgrounds and levels of expertise. They are often handled rough, especially in emergencies where clinicians are focused on managing life or death events. Regulators are hard-mounted to a wall or canister system and need to withstand the rigors of repeated connections and disconnections to other devices. When urgently required, they need to work. Regulators see a variety of fluids aspirated through them or applied to their exterior: blood, mucus, saline, bile, antibiotic solutions, bleach, Sidex, cleaning agents, and other bodily fluids all come into contact with a regulator. With other environmental issues, a regulator may get thrown into an autoclave. It should be able to handle this. So, when one considers all the mechanical, chemical, and environmental extremes encountered, it's difficult to argue that metal is not the most appropriate choice to meet these needs. Don't get me wrong, engineered plastics have made great strides in the past 20 years, but there's just no replacement for something that needs to run 24 hours a day across multiple shifts with no downtime. We chose aircraft-grade aluminum for its strength-to-weight ratio, offering the optimum blend of properties to give our devices the ability to repeatedly withstand the clinical environment's rigors. We made the conscious decision to treat the aluminum with a synthetic sapphire coating to provide increased chemical and wear resistance. Synthetic sapphire is also known as a hard coat, and outside of the military or aerospace, you won't come across aluminum items treated in this way. Unlike standard, quote, anodized aluminum, like the wheels on your car that can fade and get scratched over time, a hard coat lasts a lifetime. The coating is so durable that we need diamond-coated tools to craft your suction regulator. We chose an array of engineering-grade polymers that complement the overall design for items that we cannot construct of metal. These materials are not the plastics that you would encounter in your child's playroom, but instead are designed to survive saturated steam at 270 degrees. We use the same grade of polycarbonate found in bulletproof glass in our clear gauge on the regulator. We rate the main control diaphragm of our regulators to 125 psi. Now, keep in mind that 500 millimeters of mercury is only 10 psi, thus demonstrating the definition of over-design. We strongly feel that the devices we make need to work when needed, and we chose not to skimp on the materials in our design. We don't care about the concept of planned obsolescence. That is not what we do. When intrepid MBAs continually discover innovative ways to reduce the quality of products you buy, you can rest assured that the suction regulator we build today has the original recipe from 1983. Our all-metal design suction regulator has the optimal choice of materials, resulting in a device that will provide superior performance and last for many years in your hospital.